In the 1980s, American pilots flying the SR-71 Blackbird relied on a simple defense mechanism: speed and altitude. Cruising at 70,000 feet and Mach-3 over the edges of the Soviet border, they knew nothing could catch them. But that sense of invulnerability shattered when their threat receivers started lighting up. They were being painted by tracking radar from an unseen aircraft, sometimes hundreds of miles away. A phantom the West would soon codename the Foxhound. The Foxhound was the Soviet answer to a geographic nightmare, defending 22 million square kilometers of airspace against American cruise missiles designed to fly low and slip under early warning nets. American intelligence looked at this vast, vulnerable perimeter and assumed their high-altitude jets would always own the sky. They completely misread what the Soviet aerospace industry was actually engineering to guard it. That misunderstanding started in 1976, when a Soviet pilot named Viktor Belenko defected to Japan, handing the CIA a highly classified MiG-25 Foxbat. When Western engineers tore the jet apart, they were amused. The airframe was welded together from heavy steel instead of lightweight titanium. It couldn't turn well. Its electronics still relied on heavy, antiquated vacuum tubes. They assumed Soviet aviation was years behind the curve. But the MiG-25 was essentially a rough draft, a high-speed testbed designed to catch supersonic bombers, not a finished all-purpose weapon. By dismissing the Foxbat as primitive, the West created their own blind spot. While they laughed at the heavy steel and vacuum tubes, Soviet engineers were busy constructing a massive super-interceptor right under their noses. On the outside, the resulting MiG-31 Foxhound looked nearly identical to the Foxbat. Inside, it was an entirely different machine. The heavy steel was reinforced with titanium alloys. A second crew member was added to manage complex weapon systems, and the engines were upgraded so the massive jet could cruise at supersonic speeds without burning out its afterburners. But the real leap in engineering was hidden inside the nose cone. The Soviets fitted the MiG-31 with the RP-31 Zaslon. It was the world's first passive electronically scanned array, or PESA, radar, ever mounted on a fighter jet. This diagram shows exactly how that works. Older mechanical radars rely on a physical dish slowly sweeping back and forth to scan the sky. The Zaslon uses a static grid of hundreds of individual emitters to instantly fire electronic tracking beams in multiple directions, scanning a massive volume of airspace in milliseconds. Watching the ground returns in this animation, we can see why that speed is crucial when dealing with radar clutter. When a jet looks down toward the Earth, the radar waves bounce off everything: trees, buildings, and hills. This creates a wall of visual noise that easily hides a small, low-flying cruise missile. To solve this, the Zaslon used Doppler filtering. Because the ground is stationary, its radar return has no velocity shift. The system's digital processors mathematically strip away that static, isolating the distinct speed of the approaching missile and giving the MiG-31 a true look-down, shoot-down capability. By prioritizing these systems, the Soviets turned the MiG-31 into a heavy computational node, capable of solving the specific physics of low-altitude interception. The Soviets designed the Foxhound around a systems-over-platforms philosophy. Instead of relying on vulnerable ground-based radar stations, a flight of 4 MiG-31s could link their systems together in midair. Flying side by side, they projected a synchronized 800-kilometer-wide invisible electronic wall across the Arctic. That wall proved its effectiveness over the Barents Sea in October 1986. An SR-71 pilot was flying a high-altitude reconnaissance track, totally confident in his speed, when he suddenly spotted a bright white Russian contrail climbing rapidly from far below. It was a MiG-31. The Foxhound didn't even need to match the SR-71's altitude. Using its massive radar and long-range missiles, the Soviet jet executed a coordinated lock-on from over 10,000 feet below the spy plane's flight path. The American crew survived the encounter, but the strategic damage was done. The intelligence community now knew the days of consequence-free, high-altitude surveillance flights over Soviet territory were over. Fast forward to the 2020s, and the MiG-31 is still flying. Long after the collapse of the Soviet Union that designed it, the Foxhound refuses to retire. The exact engineering traits that made it a terrifying interceptor, a massive airframe carrying extreme payloads, a top speed pushing Mach 2.8, and a ceiling above 67,000 feet happen to make it the ultimate energy carrier. Today, Russia now fields the MiG-31K variant. It has largely abandoned its old interceptor duties to serve as a dedicated airborne launch pad for the Kh-47M2 Kinzhal, a heavy aeroballistic missile. This diagram illustrates why the Foxhound is so effective in this role. An aeroballistic missile launched from a fast aircraft doesn't have to start from a dead stop on the ground. By using the jet as a reusable first-stage rocket booster at the edge of the stratosphere, the Kinzhal inherits massive initial speed and altitude, extending its effective range to roughly 2,000 kilometers. Watching the ground radar warning radiuses shrink in this diagram, we see the real threat. Launching at such extreme velocities so high up drastically compresses the flight time to the target. It shrinks the adversary's detection window and leaves modern air defense systems with almost no time to react. The heavy, brutalist engineering the West dismissed in the 1970s ultimately gave the Foxhound the mass and velocity required to carry Russia's modern hypersonic arsenal.